for probability of x is equal to 0 when 0 is defective is given by 68/95. Similarly, when 1 is defective, the probability is given by 51/100 and what? And 90. If you use this formula. Similarly, when x is equal to 2, the number of defectives, you can substitute in this formula and you get 3/100 and what? And 90. Here, this is the probability distribution table showing relationship between x, the number of defective, and f of x, and their corresponding probabilities. We should note that the sum of f of x should be equal to what? To 1. And graphically, we can show the discrete probability distribution in this using this graph as shown below. Remember, the horizontal axis shows us x, and then the vertical axis shows us the probability of f of x. And the probabilities are represented by horizontal bars at the different values as shown in the figure below. The cumulative distribution f of x as a discrete random variable x with probability distribution f of x is given by capital F of what? Of x. This is just the sum of the what? The individual probabilities in the what? In the probability distribution table. And our x can be between positive infinity to what? To negative infinity. Continuous probability distributions. In dealing with continuous variables, f of x is usually called the probability density function defined over a set of number if f of x is greater than 0 for all x which are on the real number line, then the sum of the probabilities with respect to x should be equal to 1, where x is between the positive infinity and what? Negative infinity. And the probability that x is between a and b is equal to the integral of f of x dx, where x is between a and what? And b. For example, suppose that the error in the reaction temperature in degrees Celsius for a controlled laboratory experiment is a continuous random variable x, having the probability density function given by x squared over 3, where x is between -1 and 2 and 0 elsewhere. The question is, verify whether f of x is a density function and then find the probability that x is between 0 and what? And 1. Let's look at the solution for this problem. So where our x is between -1 and 2, this interval, when you sum the individual probabilities over this interval, it should be equal to what? To 1. Hence, when we integrate x squared over 3 dx, we shall get, you add the power here, and then you divide by the power, which is equal to x cubed over 9, and then you substitute for x equals to -1 to 2 in this expression. We shall be able to get 1. This shows that this is a probability what? Distribution. And then the second part is obtain the probability of x within 0 and what? And 1. and this one is equal to the integral of x squared over 3 dx, where x is between 0 and what? And 1. So when we integrate x squared over 3, we get x cubed over what? Over 9. And then we substitute for x between 0 and what? And 1. So the probability is equal to 1 over what? Over 9. The cumulative distribution function, capital F of x, of a continuous random variable x with density function f of x is f of x equal to probability of capital X is less than or equal to the what? Of small x, which is equal to the sum which is given by the integral of f of t dt for our x is between negative infinity to what? To x. As an immediate consequence of the definition above, one can write the two results as probability of x between a and b as the cumulative distribution at b minus the cumulative distribution value at what? At a, which is just the same as, hence our probability distribution f of x is equal to the derivative of the cumulative distribution what? Function. As we can see, when you are going back to get the probability distribution, you have to differentiate the cumulative distribution function. For example, if f of x is equal to x squared over 3 for the density function, evaluate probability of x between 0 and what? And 1. So for our x between negative 1 and 2, our capital f of x is equal to the integral of small f of x dt. So remember, our f of x is equal to t squared over 3 so when you integrate x squared over 3, you get t cubed over 9, where x is between negative 1 to x. Negative 1 to x. Hence, we can substitute t cubed over, we can substitute x, this interval, into this value here of this function t cubed over what? Over 9. Hence, we can also display our relationship between f of x and what? And x on a graph, and it can be shown to be like this. As you can see in this graph, this is f of x and this is x, and this is how the distribution looks like. So our capital F of x is going to be equal to x cubed plus 1 over what? Over 9. This is our cumulative distribution function. As I have shared with you, it is as shown in this graph. You can see that as x increases, it tends to go to what? To 1. So probability of f of x between 1 and 0 is equal to the capital F of 1 minus capital F of 0, which is, when you substitute 1 here, you get 1 plus 2, which is 1 plus 1, which is 2 over 9, minus, if you substitute 0 here, you get 1 out of 9. So 2 over 9 minus 1 over 9, you get 1 over what? Over 9. So you can be able to use the cumulative distribution to get the probability of x between 0 and what? And 1. Joint probability distributions. There will be a situation where we may find it desirable to record simultaneous outcome of several random variables. For example, if you combine one random variable with another random variable, you can be able to get the joint distribution of those random variables. Because in life, there are factors that determine a certain outcome. Rarely is an outcome determined by only one factor. So you need to have an idea of what all these factors are contributing to the outcome. Thus, several random variables will be used in those cases. For example, we might measure the amount of precipitate and volume of gas released from a chemical experiment, giving rise to two-dimensional space consisting of the outcome PV. The function f of xy is a joint probability distribution or probability mass function of the discrete random variables x and y if their joint distribution probability is greater than or equal to 0 for all x and y, and the sum of their probabilities is equal to what? Of their joint probabilities is equal to 1. Okay? Let us have an example. Suppose two ballpoint pens are selected at random from both a box that contains 3 blue, 2 red pens and 3 green pens. If x is the number of blue pens selected and y is the number of red pens selected, find the joint probability function f of xy. Solution. The possible values of xy is going to be equal to 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, and 0 what? And 0, 2. Now, f of 0, 1, for example, represents the probability that a red and a green pens are selected. The total number of equally likely ways of selecting any two pens from 8 is 8 combination 2, which is equal to 28. The number of ways of selecting one red from two red pens and one green from 3 green pens is given by 2, 1 and 3, 1, which is equal to 6 ways. Hence, f of 0, 1 is equal to 6 over 28, which is equal to 3 over 14. Similarly, calculation yield the probabilities for other cases which are presented in table what? In table 3.1 as shown below in the next slide. Note that the probability sum should be equal to what? To 1. Hence, our probability distribution function is going to be equal to 3x, 2y, and then 3, 2 minus x minus y, divide by 8, 2, where our x is going to be 0, or 1, or 2, and our y is going to be 0, or 1, or what? Or 2, and the sum of x plus y should not be more than what? More than 2. So this is the probability